Hello everyone and welcome back to Mathematics with Usman. This is my third video in my series on the topic transformation, and today we are going to discuss rotation of an object or a point. Let us first discuss the basic characteristics of the topic rotation. Students, just remember, rotation means turning of a figure about a center or the turning of a point about a one fixed point called a center. Students, rotation is an isometric transformation, which means that whenever you transform or rotate any figure or a point, its size and the shape always preserved. The third very important thing is it has three basic components. For the rotation you need center of the rotation, angle of the rotation, and last but not the least, in which direction you are rotating an object, whether anti-clockwise direction or the clockwise direction. Students, there are different cases of rotation that we have to discuss. Number one, it is a kind of a rotation in which we will rotate this point A32, which is having the following three characteristics. The center of rotation of this point is going to be the origin 0, 0. Its angle of rotation will be equals to 90 degrees and its direction of rotation will be clockwise. This angle of rotation is very much similar to saying 270 degrees anti-clockwise. Whether I say 90 degrees clockwise or 270 degrees anti-clockwise, they bring the figure to the same position. So students, let us rotate this point A with the center 0, 0 in the clockwise direction with the angle of 90 degrees. First step is join this point A to its center, which is C. So let us join them with a straight line. Now students, consider in which direction it is going to be. Clockwise direction is in this direction, so this point will shift in the downwards direction like this arrow. We have to consider the distance of this point A, how far it is from the center. Its image will be at the same distance from the center, but at an angle of 90 degrees from C. So the angle between CA and CA dash must be equals to 90 degrees, with the length of CA equals to the length of CA dash. And the angle between them should be equals to 90 degrees. So students, this should be the image of the point A when it is rotated 90 degrees in the clockwise direction. Dear students, let us now consider the same rotation, but this time using the matrices. We will consider the point A, but we are not going to write it in the point form. In fact, we are going to write it in the position vector form, means in the form of the column vector A 3 times 2. Then there is a particular matrix that when multiplied with this point A, you are going to get the same image as we have got it while using the graphical method. What that matrix is? That matrix is 0, 1, minus 1, 0, a 2 cross 2 matrix, which when multiplied with the point having the coordinates 3, 2 written in the column form, we are going to get its image. That will be equals to 2 minus 3. See students, 2 cross 2 matrix multiplied with 2 cross 1 matrix. What we are going to get? We are going to get 2 cross 1 matrix. 0 into 3 plus 1 into 2, you are going to get 2. Minus 1 into 3 plus 0 into 2, you are going to get minus 3. So see, the image of A, which was 3, 2, now becomes 2 minus 3. So this is how students you can rotate. If you don't want to use the graphical method, you simply remember this matrix, memorize it and multiply it with the point that you want to rotate, and you are going to get its image, the required image. Let us now jump into the second case of rotation. In the second case, students, what we are having the center of rotation equals to 0, 0, same as we were having in the first case. Angle of rotation is 90 degrees, the same as the first case. However, direction of rotation is no more in the clockwise direction. In fact, it is in the anti-clockwise direction, which means that our point A will now move in this direction. Means with the center, keeping the center intact, you can rotate it at an angle of 90 degrees, but like an anti-clock. So students, again, just see the distance of this point A from the center. Your image of this A in an anti-clockwise direction should be at the same distance from the center and making an angle of 90 degrees with this line and the line joining the image with the center, which is going to be this one. See students, the angle between this line and this line is going to be 90 degrees, and your point, which is the image of A, will lie somewhere over here, whose coordinates are 2, -3. Just like the case 1, we must have the matrix which when multiplied with this point A should give us matrix is 0, -1, 1, 0. It when multiplied with A having the coordinates 3, 2, and we are going to write them in the column vector form 3, 2, which when multiplied with this we are going to get the image of A, and it is equals to -2, 3. And this brings us to the third and equally important case of rotation, case number 3, in which you are given with two of the informations. Number 1, the center of rotation. Number 2, the rotation angle, which is equal to 180 degrees. See students, direction is missing over here. And the reason is whether you rotate 180 degrees clockwise an image or 180 degrees anti-clockwise, you will reach the same position. So students, for rotation, let us consider the point A, which we want to rotate at an angle of 180 degrees with the center 0, 0. It is simply the reflection of this point against the origin, so it will move in the opposite direction at the same distance from the center. Look, it is 3 units in x direction and 2 units in y direction from the center, which is the origin. So it will move the same 3 units in x direction, the same 2 units in the y direction, but the direction will be opposite. So 1, 2, 3, 3 units in x direction, 1, 2, 2 units in the y direction. So this should be the image of A when it is rotated 180 degrees against the center. So A dash will be having the coordinates -2, -3. The matrix representing the rotation of 180 degrees with the center 0, 0, it is -1, 0, 0, -1. This matrix, 2 cross 2 matrix, when multiplied with the point 3, 2, pre-multiplied with the matrix 3 with the column vector 3, 2, it is going to give you the same result. So you have to memorize this if you don't want to use the graphical method for the rotation of 180 degrees. And students, this brings us to the end of today's tutorial. As always, thank you very much for watching Mathematics with Usman. See you in another tutorial. Till then, it's goodbye.